So now we have a question here, um, where we apply the formula we have derived so far. So you have a gas in a piston cylinder assembly undergoes an expansion process for which the relationship between the pressure and volume is given by PV to the power of N is a constant. You should know that this is a polytropic process. The full stop. The initial pressure is 3 bar. The initial volume is 0.1 meter cube, and the final volume is 0.2 meter cube. Determine the work for the process in kilojoules. If A, for the first case, when N equals 1.5, second case, when N equals 0, and the third case, when N equals 1. Now, our solution. First, to solve this, first of all, we have to start indicating the parameter we're given. Now, from this, we have that our initial pressure, let's call it initial pressure as state 1. So I have a P1 equals 3 bar. The initial volume as the initial state, let's call it that state 1. Our V1 equals 0.1 meter cube. Now, and the final volume, our V2 now equals, when it's undergo the process to the next state 2, the final volume is 0.2 meter cube. Our P2 is not known yet, it's an unknown. Now we have to find the work for the process in kilojoules if N equals 1.5 for the first case. Now from our formula, we have that W equals P2V2 minus P1V1 over 1 minus N. Now I have my V2 here, I have my V1, I have my P1, but something is left or something is missing to calculate our P2, to calculate the W. Our P2 is not known yet, but we can calculate P2 from the relationship between the pressure and the volume for the process. Now, but PV to the power of N is a constant. In other words, we have that P1V1 to the power of N is equals P2V2 to the power of N. Now from here, we can make our P2 the subject of the formula. We have our P2 equals P1 V1 to the power of N over V2 to the power of N. Or in other words, we have this P1 in brackets. You have P1, then P1 in brackets V1 over. So we have this. Now I know my pressure at state 1, P1, 3 bar. This equals 3 multiplied. Also our V1. Our V1 is given by 0.1 meter cube. We have 0.1 divided by our V2 is 0.2 meter cube. 0.2. Now our N in this case, for the first case, is 1.5. So when N equals 1.5. So for the first case, when N equals 1.5, you have to, instead of writing N, you just need to put 1.5 now. Now, if you should use calculate with our calculator, we have 3 multiplied by 0.1 divided by 0.2 all to the power of 1.5. It gives 1.06 to 2 decimal places. So we have this is 1.06 bar. So we have gotten our P2. Now we can go back to our equation for the work. So we have that the work equals P2. Now P2 has been is known now. We have 1.06 multiplied by V2. Our V2 is given initially, times 0.2 minus P1 V multiplied by V1, all divided by 1 minus n is 1.5. 1.5. Now, when taking this calculation, we see that our pressure is in bar, 1.06 bar, 3 bar. Now, but we have to determine the work in kilojoules. Now, to do that, we have to first convert our pressure to in bar to Pascal by multiplying it by 10 to the power of 5. So in this form now, the pressure now is in Pascal. Now, to convert Pascal to kilopascal, I have to divide by 10 to the power of 3. So we have this. So when we convert our pressure to kilopascal by multiplying the whole thing by 10 to the power of 5, dividing by 10 to the power of 3, then we obtain our work in kilojoules. Or in other words, when we take this calculation and multiply the whole thing by 10 to the power of 2, because 10 to the power of 5 divided by 10 to the power of 3 is 10 to the power of 2, we get our work in kilojoules. So in other words, instead of writing 10 to the power of 5 divided by 10 to the power of 3, I can erase this and insert 2 here. So when your pressure is given in bar and you have to find your work in kilojoules, when you do the whole calculation, multiply everything by 10 to the power of 2. Now, when we do that, what do we obtain? When we press your calculator, we have 1.06 multiplied by 0.2 minus 3 multiplied by 0.1 divided by 1.1 minus 1.5, all multiplying 10 to the power of 2. You obtain 17.6 kilojoules. So our work done for this case is 17.6 kilojoules. We have done for the first case. Now for the second case, when n equals 0, we follow the similar procedure. And when n equals 0, we have that P1 V1 to the power of 0 equals P2 V2 to the power of 0. Any quantity to the power of 0 is just 1. So we have this. We have the P1 equals to our P2, meaning that my pressure at state 1 equals to my pressure at state 2. Or P2, meaning that if P1 is 3 bar, my P2 also will be 3 bar. What have we been able to establish from this? We know that for a polytropic process with polytropic index n equals 0, for a polytropic process, this with polytropic index n equals 0, we have that our pressure is constant. So in other words, when n equals 0, we obtain what we call a constant pressure process or an isobaric process. So our pressure is constant for both states. Now we have the P1 equals to P2, which is equals 3.0 bar. Now going to our formula for work, we have that the work W equals P2 is known 3 bar, 3.0 multiplied by V2, 0.2 minus P1, also 3 bar, multiplied by V1, 0.1 divided by all by 1 minus 0. Now this does this 3.0 multiplying 0.2 minus 0.1, which is just 3 multiplying 0.1. Now, because our operation is in bar, to make our results be in kilojoules, you just have to multiply by 10 to the power of 2. So you have times 10 to the power of 2 here. So this all gives 3 multiplied by 0.1 is 0.3, then multiplied by 100 is 30 kilojoules. So the work done for this process when our n equals 0 is equals 30 kilojoules. So I've been able to solve for n equals 0. So let's do for n equals 1. Now we are going to solve for when n equals 1.5, when n equals 0. Now the last case, when n equals 1. So when n equals 1, I told you earlier that when n equals 1, this becomes, the denominator becomes 0 and we get an undefined result. So what do? We apply the other formula that we got. We have that W for a polytropic process when polytropic index n equals 1 is given by, so we're no longer using this out, so this is out. We are not using this to calculate for n equals 1. We're using this rather, P1 V1 ln V2 over V1, or the other one, or P2 V2 ln V2 over V1. But I'm not using the other case, P2 V2 ln V2 over V1, because I will need to calculate P2 to evaluate W. But I have P1 and I have the rest. So I should, without calculating P2, you can still find the work for this other process. Now, so we have this equals 3 multiplied V1 0.1 natural log V2 0.2 divided by 0.1. Then to get our result in kilojoules, we have to multiply the whole thing by 10 to the power of 2. So we have this. So we have our 3 multiply 0.1 ln 0.2 divided by 0.1, all multiplied by 10 to the power of 2. We have 20.79 kilojoules. So we are able to apply the work done formula for a polytropic process to solve thermodynamic problems involving changes of states, that is moving from a initial state to a final state.